Okay, question 8. Partial fractions again. It's been laid out for us what we need to do. First thing then, multiply through by the whole of the denominator. And if we do that, we end up with just 4 minus 2x on the left. On the right, for a, the 2x plus 1 is going to cancel. But we're then going to multiply a by x plus 1 and x plus 3. For the b, the x plus 1 is going to cancel. But we're going to then be left with 2x plus 1, x plus 3. And finally for the c, the x plus 3 is going to cancel, leaving us with 2x plus 1 and x plus 1. Okay, subbing relevant values that are going to make some brackets 0, so x equals minus 1 would be a good place to start. So 4 minus 2 bracket minus 1. That's going to disappear. That's going to disappear there, but we are going to have the b term. Okay, so if minus 1 goes into there, we get minus 2 times plus 1 is minus 1. Minus 1 plus 3 is 2. There we go. So then on the left, 4 plus 2 is 6, minus 2b, and so b is going to be minus 3. Okay, next one, x equals minus 3 would help. So this time 4 minus 2 lots of negative 3. That's going to knock out that first term and that second term, but the last term, the c term, will actually have some value. So 2 times minus 3 is minus 6, plus 1 is minus 5, minus 3 plus 1 is minus 2. Minus 2 times minus 3 is 6, plus 4 is 10. That's 10c, so clearly then c equals 1. And finally, to knock out the 2x plus 1 term, we're going to let x equal minus a half. And that's going to knock out the b term and the c term, but it'll leave the a term. So minus a half plus 1 is going to be a half. Minus a half plus 3 will be 2.5, or 5 over 2. Any doubts about any of that, you can always just check it on your calculator. Okay, so minus 2 times minus a half is plus 1, so then add it to the 4, that makes 5. Here we've got 5 over 4a. So if we divide both sides by 5, we get 1 equals a quarter a. Multiply 3 by 4 and we get a equals 4. Okay, so then let's just go back and state then our f of x. So a, so a over 2x plus 1, where a is 4, so that's 4 over 2x plus 1. b over x plus 1, where b is minus 3, so minus 3 over x plus 1. And c over x plus 3, where c is 1, so 1 over x plus 3. And finish. So in b part 1, we're going to integrate f of x, where f of x we've established from part a is 4 over 2x plus 1 minus 3 over x plus 1 plus 1 over x plus 3. So that's what we're trying to integrate. Now notice they're all reciprocal functions, and the denominators of each of those are all linear. So in each case, we're going to use ln. Okay, so the numerators, though, remember, are just constant multipliers effectively, so that 4 is just a 4. But then we get into our ln of the denominator, and remember the inverse chain rule. So here we've got 2x plus 1, so we need to divide by that 2 according to the inverse chain rule. Here then we've got minus 3 ln of x plus 1. Coefficient of x in this case is 1, so in terms of dividing by 1 from the inverse chain rule, well, that doesn't really have any impact. And similarly here we've got 1, which is 1, ln of x plus 3, and again inverse chain rule with a coefficient of 1. It isn't actually going to do any work. See if we can tidy some of that up. So 4 times a half is 2. Oops. Keep the modular signs at this stage until we substitute in values. Okay, minus 3 ln of x plus 1 plus ln of x plus 3. Now it doesn't ask us to merge them together yet, so you could just stop there. So I'll underline that. But I will also at the same time push on to show how you can merge the three ln functions together. Now a 2 ln minus a 3 ln plus a 1 ln isn't going to work. So we need a ln minus a ln of something else plus a ln of something else. So in order to get rid of the 2 and the 3, we can apply the power rule, push that 2 inside, and that then becomes 2 of 2x plus 1 squared. Change that to normal brackets because anything squared will be positive anyway. Similarly over here we have ln of x plus 1 cubed. I've left the modular sign there because a cubed number isn't necessarily positive. And plus ln of x plus 3. Okay. Now we are ready to sort of gradually merge the ln functions together. So we've got ln of this minus ln of that. Well, that means that we can merge the two together into ln of 2x plus 1 squared divided by x plus 1 cubed. Okay, and then we've got the addition of two logarithms, which means we can multiply the insides. So this time then the numerator is now going to be 2x plus 1 squared x plus 3 over x plus 1 cubed. Okay, and that's the second stopping point. So you could perfectly well stop there, or you could have pushed on to there. Okay, in part 2, we're integrating then f of x between 1 and 2. Well, we've already done the integral here, and my second version of that was the combined ln function. So I'm simply going to say, well, the integral of f of x between 1 and 2 is that between 1 and 2. Okay, so that leaves me with this. So I'm then just going to start to substitute in the 2 and the 1. Okay, so with 2 going in then, 2 times 2 plus 1 is 5. 5 squared is 25. 2 plus 3 is 5. 2 plus 1 is 3 cubed is 27. Okay, 1 going in, we've got 2 times 1 is 2, plus 1 is 3, 3 squared is 9. 1 plus 3 is 4. 1 plus 1 is 2, 2 cubed is 8. Tidy that up a little bit. 25 times 5 is 125. 9 fours are 36. Um, 36 over 8 can be simplified to what? To 9 over 2. Okay, and then because we're subtracting two logarithms, we can divide the insides. So we've got 125 over 27 divided by 9 over 2. Okay, which is the same then as ln of 125 over 27 times by 2 over 9. And you can potentially just do that on your calculator. 25 over 27 times by 2 over 9, 250 over 243. Okay, and finish.